Ladies and gentlemen, returning from last year, Maria.
I have my notes on my phone because I made my slides in Canva, which was not a great idea. Don't do that. We're going to talk about code prompts and stories, and I'm going to compare coding with screenwriting and storytelling. So we're going to go through several very popular storytelling principles and see if it applies to code. And the whole structure is in 3 acts, because usually the movies and stories, they have 3-act structure, and I thought that might be relevant here as well. I do have some spoilers to some movies during this talk. They are not new movies, so you've probably seen them. But just in case, if you hate spoilers, maybe don't listen to this. So yeah. In the first act, we're going to look at like 3 principles from screenwriting and see how it applies to code. So the first one, a very famous one, probably the most famous, show, don't tell. If you've seen the movie Mad Max Fury Road, it's a good example of this principle in the movies. They have no exposition, almost no exposition, and they don't explain to the viewer what's happening in the movie. What's the citadel? What's happened with water? Why is this happening? And they only rely on action, and we don't have any scenes where somebody explains to the audience what's going on. And in programming, we can look at this with a couple of examples from here. So in this method, you can see there is 3 lines of comments. The method is named very like a full sentence, and we have several if statements that go step by step and almost don't trust the user to understand what's going on. If you worked with Cloud Code, you may be seeing that sometimes it adds a lot of comments when it generates the code, and they are usually very redundant. So this is an equivalent when the character turns to the camera and just explains their plan, and we don't want to have that. So if we remove all that, we can end up with this smaller, more cleaner method, which just named publishable, and you can understand what it's supposed to do. And from the one line, you can also understand what checks it does. And it reads better. It also doesn't have any clever metaprogramming or anything like that. It's just very clear, very readable instructions. And you don't need any comments here. It's very self-explanatory. Another principle that you also might have heard of, it's Chekhov's gun. Chekhov is a Russian playwright that wrote multiple plays in Russian. It's internationally famous as well. And Chekhov's gun is a concept when there is a gun on a wall in Act 1, it should go off by Act 3. So if there is something that you saw in the beginning of the movie or the story, it should pay off at the end. With Back to the Future, we see this in this flyers about the clock tower. We see this in the beginning of the movie. All the details that are mentioned in the beginning, they pay off at the end when they need to actually go back to the future. Let's look at the code again. For this principle, if you look at this, you might think, oh, we have multiple things that's going on here. We have maybe a logging, maybe we check inventory, and going into this, you might think, I need to understand all of this. But if you look closer, you can see that a lot of this is not used at all in this class. So a lot of things here are just guns on the wall that never fire. And how it might have happened, like not intentionally, maybe there was a legacy code, maybe at some point it was important. We could also think about this like in a different way. Maybe there is actually an audit log in this somewhere. Maybe there is even an interface, but nobody uses it, for example. So it can go even further from just a direct code. And if we remove all of that, again, we end up with a very short, very readable class that only uses one dependency, and we can understand what's going on right away. It's easier to read. You don't overthink, and you don't like assume that maybe there was an audit log at some point, maybe somebody deleted it, maybe there is a bug. So it makes it very intentional, and everything you have in the code should be there for a reason. We shouldn't have any laying parts that are not used. The next principle I wanted to mention is every scene must have a turn. Robert McKee is a very famous person in screenwriting. It's almost like Martin Fowler in programming. And his book, Story, is foundational for screenwriting. And the quote, I'm not going to reread the quote, but the point of this quote is that in every scene that you have in the movie, something has to change at the end of the scene. If nothing changes, then it shouldn't be there at all. So it should either change the character or the power dynamic, or we need to learn new information, so something has to change. In the inception, we see the change in every scene of this movie. We either learn new information about the dream world or how everything works, or we learn new information about the characters, about the background, about the rules of the world that we're in. So every scene there is very intentional, and it has to be present. In code examples, this is like a very fake code example again, but to illustrate this principle, again, if you see the name of the method, you can assume, oh, it handles subscriptions. And if you look closer, you can see that it doesn't change anything, actually. It just reads several values, and it doesn't do anything with them. In this renew subscription method, however, we can see that we actually changed the state of things. We send an email potentially. And also in the language itself, we have methods with explanation signs that indicate that there is a change in the value that is happening. So after all those principles are applied, we might end up with the first draft of something, and the next steps would be to edit this draft. And editing is very similar to refactoring. Again, very famous phrase, writing is rewriting, and in our case, rewriting is refactoring. The first draft we usually get is a prototype. In our case, sometimes the first draft is good enough, but when time passes, you need new features, and it might require editing, or we just see that when everything is done, maybe a different pattern should be applied. And with each iteration, we can improve clarity and readability of the code. And the same applies to screenwriting. With this example from the movie Good Will Hunting, I wanted to explain how the approach "kill your darlings" works. This is, again, a famous phrase, and there is no confirmed origin of this. Some people assign this to Faulkner, some people assign this to Stephen King. I think he used this phrase in one of his books. So it's originated from writers, and then it went to screenwriting in the 90s, and it's still used when people talk about screenwriting. So in Good Will Hunting, if you don't know the plot, some spoilers, there is a main character, Will, who has a genius level of IQ, and he works as a janitor at MIT. He gets into trouble, and he's forced to go and talk to a therapist regularly, who's played by Robin Williams. And the whole movie is about characters and their relationship, and it's a very character-driven drama movie. But originally, the screenplay that was written, it included the huge part with an essay plot, and it was more of an action thriller instead of a character drama. And this is like a classic movie, so if it was a very action-driven drama, probably it would have been very forgettable and didn't make an impact that it did in the industry. And if you're looking at that and thinking, oh my God, this is Jason Bourne, yes it is, Matt Damon is in this movie. And they won an Oscar for the screenplay with Ben Affleck. They removed completely this NSA plot that was unnecessary and only left the parts that were about relationship between therapist and the main character. So removing parts from the screenplay made it significantly better. We have more examples of similar situations with the editing. In Star Wars, like the first Star Wars movie, it was not in the state that we saw it, because the original cut was very different from what we saw in the theaters. And it kind of continues to be different because George Lucas keeps adding more CGI, but that's a different thing. So the original Star Wars, they were saved in the edit room, and there is a very good YouTube video about this if you want to dig deeper into this. Basically, they changed the whole pacing of the movie, they moved the scenes around, and it was completely different. And now it's a classic movie, and it shaped the cinema in a way. And it was changed completely on the last step of production. They won an Oscar for the editing in 1978. Marcia Lucas was, at the time, wife of George Lucas, and she collaborated on this a lot, so she saved the Star Wars, basically, that we know right now. So refactoring is very similar to editing. Can you tell the same story but differently? It's similar to cutting a character, simplifying the plot, reordering the scenes, and if you can see the code on the slide, this is intentional because it's a very long method that shouldn't be like that. It has 8 arguments, which is already a code smell by itself. But again, it might have happened just during legacy iterations. Nobody intentionally starts the method and thinks like, I'm going to put 8 arguments into the method. And if you do, please don't do that. This is how it might look after the refactoring. Again, it's shorter, more readable, clear. You can see what's happening. You can read this like a story from beginning to the end, and you can understand what's going on in each line. And it makes you understand this code faster, and it just simplifies everything for the reader. You might be thinking like, okay, this comparison kind of works, but what about the plot twists? Like in the movies, there are sometimes a plot twist that you didn't expect, and I don't want my code to surprise people. And it is kind of true. Screenwriting rewards surprise, the twist ending, the subverted expectations. And if you have a lot of surprises in your code base, this is probably a bug. So does it still work? Let's look at this example with Sixth Sense movie. And I'm going to totally spoil the ending, but you've had time. It was out since 1999. I think it should be fine. And if you were born after 2000, don't tell millennials, because we cannot comprehend that anyone was born after 2000. So the plot of this movie is Bruce Willis plays a therapist and a child psychologist, and the kid who's he working with, he has ability to see dead people. And throughout the whole movie, you're kind of trying to understand, is the kid just really seeing dead people, like what's going on? And by the end of the movie, the plot twist at the end is that this whole time, the therapist character was dead. So, don't scare me. I hope you saw the movie. But it looks like a very good plot twist, and it is. But if you think about this movie from the beginning, or if you rewatch it after that, you can see that all the clues were there from the beginning. The opening scene starts with he gets shot, and then it jumps 1 year after, and we kind of assume, okay, he recovered, like everything's fine, maybe it's okay. Then you see, like, he tries to talk to his wife, and she doesn't talk to him, and you assume, okay, they may be in a fight, so it's like, maybe this is a normal situation. But when you rewatch it, you can see that he doesn't talk to anyone except this kid in the movie who sees dead people. And he doesn't touch furniture. Basically, he does not interact with anything. He's essentially invisible to everybody else. So my point is with this, it might seem like a plot twist, but it was very intentional, and it was planned from the beginning. So if it's a good screenplay or like a good movie, it will be planned from the beginning. And this is what we do when we code. We know where we want to get, and we do plan everything from the beginning as well. So I think this kind of also supports my comparison with this example. Now we are at Act 3, and Act 3 in movies and stories are usually very difficult to do. And ironically, it was very difficult to do for this talk as well. So we'll see how it goes. So I wanted to compare everything that we just learned and see if it still applies to prompts. And the question mark is doing a lot in this slide. Let's see how we moved towards this natural language during the whole time, basically. All the languages, they were trying to do to do like more abstraction on the machine code. And a lot of people comparing what's going on right now with prompts, with development of the compiler. So this is like the next evolution of our profession, and this is what we supposed to do now. With Ruby, I wanted to mention that we specifically, I think, were significantly closer to natural language than other languages. And this was always part of the this was always a great part of the language that a lot of people love, that you can actually write the code that you can read like a sentence. And now we are at the stage where we're writing prompts which are in natural language, and we need to communicate our intent, and we don't need to write specific commands. We almost don't care how it executes, it seems. So does all of those principles still work with this? On the left, you can see like a very broad statement that asks to review the code and tell if there are any issues. And if we try to apply show don't tell principle, and we need to be more clear and specific, the prompt on the right will give you a better result. They both will work, but on the right, at least at the time of this talk, it will give you the better result because you are more specific. With Chekhov's gun, we need to provide sufficient context. We need to provide very specific information that will lead us to the specific result that we intend to get. You don't need to dump the whole code base to the prompt. You will run out of context window, it will get you like worse results. If you specify exactly which parts of the code are relevant to your task, it will be giving you better responses because it only uses the information that relevant for this specific prompt. And with every scene must have a turn, we can break complex prompts, tasks into subtasks. Again, don't put everything into the prompt with a lot of instructions that you need to find all the bugs, fix them, write tests, update the docs, refactor everything that you can find. It will give you some kind of result, but it will not be good. The more specific you are, the better the result will be. And also, this is an opportunity to use prompt as the orchestrator and use sub-agents to execute specific things separately. So you can make a plan, you can create a spec, and then you can use different agents to do very specific things that you need specific results at the end. Like one can write tests, another one can debug specific parts, and investigate things step by step and write the results that you need. And refactoring editing is even more important right now because AI can generate a first draft really, really fast. The more code doesn't mean that it's better. As developers, we now need to figure out if we even need this feature. Do we need this code? If you can do it, it doesn't mean you should. And we're shifting more towards architecting. This is, I think, similar to what was mentioned in the first talk today as well. And we are still responsible for every line. With code generation, we should not forget that this is our responsibility to make sure that it works and that everything is still correct and everything should be there, only the parts that we need to be there. We don't need to over-engineer things when we don't have to. We are at the end credits, and at the end credits I wanted to mention that all of this also applies to other areas. The technical design docs, the Slack messages you write, any emails or PR descriptions, or conference talks as well. So you can apply all of this to different areas of your life. And after credits scene is the books I wanted to recommend. If you want to read further on those topics, the first row is books related to programming, 3 fundamentals, clean code design patterns and refactoring. And I also edit AI engineering book, which was, I think it's 2024 it came out, but it's still quite relevant. So you can still read it and find useful information there. And it was a bestseller when it came out, so it's a really good one. And the second row is if you want to read more about screenwriting. Again, like very foundational books, and a very good hobby if you're an introvert. You don't have to talk to people, you just read the books. And also you can annoy all your friends when you will be able to guess the endings of a lot of movies. So yeah, that's all from me. Thank you.